Here's a very quick fact that's gonna require a quick proof. If n is bigger than 3, then n plus 2, and n plus 4 can't be prime. Now, why bigger than 3? Why not 3? If n is 3, you'll have 3, 5, and 7, and look at that, they're all prime. Okay, so I guess we have a couple of cases to look at. N being prime is of the form 6n minus 1 or 6n plus 1. If n is equal to 6n minus 1, that implies n plus 2 will be of the form 6n plus 1. That's okay. But that would imply that n plus 4 would be 6n minus 1 plus 4, which is 6n plus 3. That's not good. Okay, so n cannot be of this form. This is out. What if n is equal to this? If n is in the form 6n plus 1, that implies that n plus 2, will be in the form of 6n plus 1 plus 2, which is 6n plus 3. But a prime number can only be in the form of 6n plus or minus 1. That is, if n is of this form, you can have n plus 2 being prime. And above, if n was in this form, yes, you can have n plus 2 being prime. But you can't have n plus 4 being prime. Okay, that completes the theorem. Well, let's formally say it. So, n can only be of, you know what, let me say that right above. A prime number can only be of the form 6m plus or minus 1. That is why the first thing I do is I let n be 6m. I did that right here, and we ran into trouble. We were able to, n was okay, n plus 2 was of one of these appropriate forms, but n plus 4 failed. Okay, here, n is of one of the two appropriate forms, but n plus 2 failed. I don't even care about n plus 4. How can you have 3 primes of this form if that number is not a prime? Okay, so now we say, as a result, n plus 2 and n plus 4 can't all be primes, prime numbers. So you may say that, oh, you can have triple primes. Okay, now if you're thinking that they have to differ by 2, you're correct. But a triple prime will be of the form n, 2 more, and then 6 more, or 4 more from this. Because as a result of this theorem, we know that you can have 3 prime numbers that all, where they go up by 2, up by 2, up by 2. No, You can't have that. So we'll call it n+6. So n+2, n+6. If they are all prime, we call it triple prime. Not twin prime, actually triplet prime, excuse me. So triplet prime. So maybe 3, 5, 9. No. How about, well, we can't have 11. So how about 13, 15, 17? No, because of the 15. Oh, wait. Yeah. No, that should be 19. Okay, so no, that didn't work. Well, how about 19? Yeah, you can't have 21. You can't have, say, 29, 31, and 35. No. How about 31, 33? That doesn't work. And then 37. 37. No. 41, 43, and 47. There it is. Those are triplet primes. This is n, this is n+2, and this is n+6. 41 plus 2 is 43. 41 plus 6 is 47. So these are triplet primes. They can't be like consecutive. You're not going to have 41 consecutive odd numbers. They'll never happen. I know that. We just proved it. This must be of the form 6n-1. This has to be of the form 2 more 6m+1. That's okay. But this would have to be of the form 6m+3. That's not okay. Now, why if you add 2? Why if you have 6m+5 is that of that form? So let's look at that. You have 6m-1, then you add 2 to this, then you add 4. You may say, wait a minute, that's not of the right form. Yes, it is. 6m+5, I can add 0 like that. And so I added 0, but then the associative law tells me that I can do the following. I can add the 5 and the 1 and then take away a 1. So this is 6m+6 minus 1. I can factor out a 6 from here. So it's in the form of 6n-1. This is a prime number. 6n-1 and 6m+5, they're of the same form. Okay, like 6 times 6 is 36 minus 1 is 35. So 35 is 6 times 6 minus 1 is also 6 times 5 plus 5. So I wrote 35. It's a multiple of 6 minus 1, which is a multiple of 6 plus 5. They're always the same. These are always going to be the same. Because 6n+5, if we take away 6n-1, we're going to have 6m. Thought they would differ by 6. If you add them, no. Okay, scratch that. So yeah, anything of 6n+5 form is 6 times a different integer minus 1. Okay. Add 1, take away 1. this is a multiple of 6, and then take away 1. That finishes this video. If you like proofs like that, please subscribe to my channel. See you guys in the next video. Thanks for watching. Don't forget, as always, watch and learn.